Okay, so a bubble sort is one of the most famous sorting algorithms, but it's quite a lot hard to visualize. There's a lot of really strange YouTube videos of people acting it out and stuff, which you're welcome to have a look at. But so let's imagine we're trying to sort out our data above. So we've got our data there in some kind of data structure, and our positions we're going to refer to. Some languages use start at the position 0, some start 1. So if I ever refer to them, I'm just going to start 1. Okay, so a bubble sort algorithm works by comparing the data in small pockets thought of as bubbles, and that's why it's referred to as the bubble sort. So it would start by comparing the first two pieces of data, so 12 and 5. And what it would do is, let's say we're sorting it from smallest to largest, it would just compare those two, ignoring the rest of the data because it doesn't know what it is till it looks at it. It would look at these two and go, right, well, 12 is greater than 5, so I need to put 5 in position 1 and 12 in position 2. Then it would look at the next set. So obviously 12 is now in position 2, isn't it? It would look at the next set and go, well, 12 is smaller than 55. So they're currently, if I'm just looking at those two, they're in the correct position. Then it would go again. And it would go, right, 55 is greater than 7, so I need to swap those two over. So 55 will become position 4, 7 will become position 3. Then it would look at 55 and 23 again. It's going to have to swap. So 55 goes to position 5, 23 goes to position 4. And then again, looks at 55 and 65. According to just those two, they're correct. 65 and 75, they're correct. And then 75 and 21, they're going to have to swap. Now, I'm not going to keep going through this because I haven't made the PowerPoint to keep going through it, but you get the idea. So what happens now is it will go through again for these two, and then again, and then again, and it keeps going and goes back. And the amount, if we consider what we've just seen, so it's compared those two, then those two, then those two, those two, those two, those two, and those two. That's known as one loop. Okay, that's known as one loop. It's going to loop through that, the length of the data set minus 1. And that sounds really random, but I'll try and explain to it. So we've just done one execution of a loop. What it would actually do is that same loop 7 times, and that by doing it 7 times, it would guarantee that the data is in order. Okay, the reason being, if we try and work out what's going to happen, the reason it does it 7 times is because our length of the list is 8, so it only needs to do it 7. And the reason it only needs to do it 7 is because we don't know. It could all be in order after one pass. It might not. Okay, we don't know if it's going to take all 7 passes or not. But the only thing we can guarantee, because we don't know what mess the data's in, we can guarantee as it's doing these small comparisons, at some moment it's going to come across the largest number in the data set. When it finds the largest number in the data set, which in our case was 75, which was in position 7, I think, but at some point in that first pass, it's going to find the largest number. Every time it compares it, it's going to obviously keep swapping it until the largest number is in position 8. All right. So in one pass, I can only guarantee that the largest number is in its correct position. And then on the second pass through, the only thing I can guarantee is that 65 would have ended up there. And on the third pass through, I could have guaranteed 55 would have ended up there. I mean, these could have been done in less steps, but we're talking about guarantees, worst case scenarios. So, like, worst case scenario, I can guarantee that's their position 1. That's in the correct piece of data in position 7 after the second loop, position 6 after the third loop, etc., etc. So the reason it's n minus 1 is because, let's say our length of our data structure is 8. If we did 7 passes, I can guarantee the back 7 are all in the correct positions. Therefore, that must be in its correct position. Okay, so it's worth trying to understand the n minus 1 rule. So the bubble sort would keep looping, and eventually the data would all be in order. That's imagining we'd loop 7 times. Okay, we can guarantee that all that data would have been in the right order.